G'day everyone. Day 5, regulated low volt power supply. I'm putting this together because I have some other projects that I want to do that require a sub-volt but fairly high current, like below an amp power supply. Now my bench supply can definitely do that, but its accuracy and regulation of the metering is not great at sub-volt kind of region. So I thought I'd put together this little circuit that can be provided with like 5 volts, either current limited or it can do its own current limiting, or maybe V-bus, like could be USB based or power bank, but a USB power bank could feed it. But it's really simple. It actually uses the power LED. So there's a red LED here that's running about 10 milliamps. That has a 1.9 volt forward voltage, and we're just using the spare op amp in an LM358. We're using an LM358 because its common mode range includes the negative rail, so you can go all the way down to 0. Any rail-to-rail op amp will be fine, so a more modern device is great, but the LM358 is super cheap. I have a bunch of them, and it'll work fine in this circuit. So you don't even need this technically. You could actually feed the divider here directly from the LED reference voltage, but I chose to buffer it because then at least any load impedance that it might see won't vary very much. Not that regulation is a huge deal for this circuit, or accuracy and temperature variation, etc. Really, all we're doing is having a closed loop around a pass transistor. So I used a TIP31C because, again, I have a bunch of them. It's a big TO220 device, and if you're dropping from 5 volts to like tens of millivolts, then it's at an amp. There's going to be watts of power dissipated there, so it doesn't hurt to have a big power device. I don't think I'm actually going to do that, at least not for very long. But if you're running much lower currents, you could get away with a 2N2222. One of the old metal ones would be great, or even a 2N3904. Any old transistor. I mean, the great thing about having the op amp in the loop is that pretty much any transistor, as long as it has a reasonable beta, can be directly connected in this circuit. This particular device is kind of old, right? So it's a power device, so its beta is pretty low. It's below 100. It's about 80 something. So if you do the math, it needs maybe 10, 12 milliamps at the kind of currents you would expect at maximum load, but that's fine. The LM358 can put out about 20 milliamps max, so it should be just fine. Most of the time it won't be providing that much current at all. This resistor, the 22 ohm resistor, I mean, I don't even really think it needs to be there. I just put it in for some arbitrary sense of protection against shorts, mainly when I was assembling the circuit. The 1K resistor here on the sampling net also is the same thing and might actually cause some instability. It's adding a pole with the input capacitance there, but it works fine. There's 100 nano on the output. Don't put too much capacitance on the output. It can cause instability as usual, but I think because this whole circuit can be made super slow by putting a cap across the feedback net here, unless you experience problems, this should just work absolutely fine. There's 100 microfarad on the input just to stiffen the input a little bit against supply variation. But again, I mean, this is a linear regulator. It's meant to do all of that for you. The load regulation looks okay, but I haven't done Bodie plot or anything like that. If you want to add current limiting, you can totally add current limiting with a pretty simple circuit. This is the pass transistor. All you do is add another transistor with an emitter, with a resistor in the emitter circuit of the TIP. This will drop, up to the forward base emitter forward current of forward voltage of this transistor. This is just a 3904, which has plenty of collector current limit, and it's just going to steal the bias from this. That will eventually rail out the loop and shut down regulation, but that's exactly what current limiting is meant to do. Once this forward biases this transistor, it turns on, steals current from this guy's base drive, so the voltage can't rise any higher, and that current that would otherwise have gone into the base bypasses and goes into the load, so that this doesn't gain it up. It's super straightforward. You've probably seen it everywhere. It's how current limiting is generally implemented on BJT pass devices, and it doesn't even need to be a BJT. Actually, you can still drive from a FET pass transistor as well in an LDO, but it's normally done on chip for you in modern devices. This is a table of reasonable values. These are approximate sense resistor values, kind of the nearest E12 value that'll give you vaguely this current as a maximum. If you want precision, obviously you could use a pot, or you could have an amplifier to amplify a sense resistor. Note that the regulation is after the sense resistor, so that it's in the loop and its drop should be removed from the circuit set point voltage. When you get down to low currents, obviously your pass transistor does not need to be the DOP or other large power transistor. It can be any old transistor. Of course, do the math, see if you're dissipating too many watts. Physically, I built the prototype here, super ugly on one of these little circuit boards. It works fine. It's currently set up for about the 1 volt of maximum travel, so that the full scale on the pot is about 1 volt. You can change that with these resistors here. You can switch between one or more of them to give you multiple ranges. I want a device that has about a 1 volt range and has a sub 150 millivolt maximum range over the full span of this 50k pot. This is a 50k linear pot, by the way, so it's a B, not an A, just so the range on the actual, when I go to mark up and calibrate the knob, it will be, linear and nice and spread out for me. In terms of marking that out, that'll just be an approximation. If you want an exact voltage, you can put a meter across the output. These are the output wires here. I'm running it off my power supply at the moment, but I can tend to hook it up to a USB connector. And I will add some switching. It's always good to have a load switch. It's strange how many modern power supplies that you buy are just so cost reduced that they leave out the damn load switch. The most fundamental thing that you would ever want is the ability to turn the load on and off quickly and easily. And a lot of power supplies don't have that, and I think it sucks. The other switch I'll use to set the range, I was thinking about using a switched pot, but that's kind of annoying too, right? Because then you have to change the voltage level. You can't just toggle it on and off. Yeah. Anyway, I'll probably 3D print a little front panel for it, and to mount these guys on. I wrote some code a while ago that makes a little L-shaped, I guess you call it a bracket. It's really just a bracket with some gussets that has whatever holes you want to define, and it's easy to define those just with an array in OpenSCAD. So I can generate parametrically a little device that a little shape that I can easily print that will implement the front panel, basically just for convenience. I might actually end up taking it all off the board and just air wiring it, or putting a little circuit board in there. But for now, this works just fine for what I wanted, which is something that can give me an easily adjustable 100 millivolt or so supply for testing out things that might run on fairly low voltages. Alrighty, quick and easy one today with some utility, and it's actually a circuit. It's not me rambling on about magnetic things. I guess it depends on whether you're super into magnetic things. I think magnetism is really cool, and it's one of those forces of nature that, well, pretty much all of our technology is based on electromagnetism, right? Apart from nuclear stuff. So it's certainly interesting to know how magnetism works. Alrighty, see you tomorrow. Bye.